Have you ever looked up at the night sky and just wondered, how big is all of this? Where do we come from? And the big one, are we alone? For thousands of years, humanity has been asking these questions. Today, we're going to explore that incredible story, our journey to find our place in the cosmos. You know how it is. We get so wrapped up in our daily lives. A missed train, a tough day at work, some silly argument. It can feel like the end of the world. But then you zoom out, way, way out, and you realize all of our triumphs and our troubles, the whole human story is happening on this tiny, fragile planet. It's just a little blue marble floating in this vast cosmic ocean. And somehow that perspective changes everything. So, to even start talking about the size of the universe, we need a much bigger measuring stick. And that's where the light year comes in. Light is the fastest thing there is, period. It moves at an insane 300,000 kilometers every single second. To put that in perspective, a beam of light could zip around the entire Earth 7 times in the blink of an eye. A light year is the distance that beam of light travels in one whole year. And yeah, that's a very, very long way. Okay, and here's where that cosmic speed limit gets really mind-bending. Because it takes time for light to travel, looking deep into space actually means you're looking back in time. The light from a star that's 10 light years away, it's been traveling for a full decade just to reach your eyes. So you're not seeing that star as it is right now, you're seeing it as it was 10 years ago. The entire night sky is basically a time machine. So with all that space out there, just how many chances for life could there be? Well, let's just run the numbers for a second. Astronomers figure there are about 100 billion galaxies we can see. And each of those galaxies has, on average, another 100 billion stars. So the number of planets, it could be somewhere around 10 to the power of 22. That is a 1 followed by 22 zeros. It's a number so big it's hard to even imagine. And our Earth is just one of them. For thousands of years, we've just stared up at the sky, trying to make sense of it all. So next up, we're going to look at how a few brilliant people, sometimes using shockingly simple tools, completely redrew our map of the universe. Get this, about 2,000 years ago, a Greek mathematician named Eratosthenes is in the Library of Alexandria, and he reads something fascinating. He reads that in a city south of him, on one particular day of the year, a vertical stick casts no shadow at high noon. But where he is, in Alexandria, a stick does cast a shadow at that exact same time. And he has this aha moment. He realizes this can only happen if the surface of the Earth is curved. So, using just the length of that shadow and the distance between the two cities, he calculated the circumference of the entire planet. And he was incredibly accurate. All it took was a stick, a shadow, and one very clever mind. For centuries, the worldview that just made the most sense was Ptolemy's model. It put us, Earth, right at the center of everything. I mean, it feels right, doesn't it? You can literally watch the sun and the stars move across our sky. It feels like we're standing still. But then, in 1543, this guy named Nicolaus Copernicus drops a bombshell of an idea. What if we're not the center? What if we're just another planet going around the sun? This was a massive deal. It basically demoted humanity from the center of the cosmos to being just a small part of a much bigger show. Now, this shift in thinking didn't happen overnight. It was more like a slow, deliberate piecing together of a brand new cosmic puzzle. You had Eratosthenes, who gave us the scale of our own planet. Then Copernicus came along and proposed a whole new layout. And after him, Johannes Kepler fine-tuned it, discovering that planets don't move in perfect circles, but in ovals or ellipses. Each discovery was built on the one that came before. So once we finally understood the basic layout of our solar system, the next logical step was to get to know our neighbors a little better. And as our tools got more powerful, we found out that the reality of these other worlds was way stranger and way more extreme than any of the old myths. The ancient Romans named Venus after the goddess of romance and Mars for the god of war. The reality, though, well, it's a bit different. Venus is a literal hellscape. It's hot enough to melt lead, with an atmosphere that would crush you, and it rains sulfuric acid. Mars isn't some great battlefield. It's a freezing, barren desert. It's the perfect example of how science replaces these old poetic myths with a truth that's honestly much more fascinating, and sometimes way more terrifying. And speaking of myths, back in the late 1800s, an astronomer named Percival Lowell was looking at Mars through his telescope, and he became absolutely convinced he saw a network of canals. He thought it was proof proof of an intelligent Martian civilization building these massive irrigation systems. And for decades, this idea of Martians totally captured the public's imagination. It wasn't until we got much better telescopes and actually sent spacecraft there that we learned the truth. They weren't canals at all. It was just an optical illusion. As our view of the cosmos got bigger, our understanding of its basic rules had to change too. Albert Einstein basically turned physics on its head with a pretty simple thought experiment. Let's try it. You're in a car, you throw a ball, their speeds add up. Easy enough. But light is different. Its speed is absolute. It doesn't care how fast you're going. The speed of light is always the same. So Einstein realized, if the speed of light can't change, something else has to. And that something else is time and space. They aren't fixed. They're relative. They can bend and stretch. It's a truly wild idea, and it all started from just thinking it through. All this exploring, all this new knowledge, it all eventually leads us right back to that one huge question. If there are that many planets out there, that one with 22 zeros, could ours really be the only one with life? This is the question that drove us to finally send a message of our own out into the great cosmic dark. So, when we think of aliens, we usually picture something out of Hollywood, right? Little green guys with big eyes. But Carl Sagan had a different idea. He argued that life would just adapt to whatever environment it's in. I mean, here on Earth, we have everything from tiny bacteria to giant blue whales. So why would we assume aliens would look anything like us? Sagan even imagined that on a gas giant like Jupiter, where there's no solid ground, maybe life would evolve to be like these giant, kilometers-wide gas balloons, just floating around in the thick atmosphere. So in 1977, we didn't just look for messages anymore. We sent one of our own. The Voyager 1 and 2 spacecraft were launched on this epic tour of the outer planets, and their final destination was, well, interstellar space. They are now the farthest things humans have ever made, carrying a greeting from us to any civilization that might, one day, find them. Attached to each of those Voyager probes is a golden record. It's basically our message in a bottle. A team led by Carl Sagan designed it to be a time capsule of our world. It's got greetings in dozens of languages, music from all over the globe, and the actual sounds of our planet: wind, thunder, whales, even human laughter. It also includes a map showing any potential finders how to get to our solar system. It's this beautiful, hopeful expression of who we are, sent out into the universe. You know, this whole journey, from a simple stick in its shadow, all the way to a message sent to the stars, it all brings us to one final, incredibly powerful realization. The cosmos isn't just something out there for us to look at. We are deeply, physically connected to it. And here is maybe the most humbling discovery of all. After centuries of looking through our telescopes, we've come to realize that everything we can see, every star, every galaxy, every planet, all of it makes up only about 5% of the universe. The other 95%? It's made of invisible dark matter and dark energy, things we know are there but we can't see and we barely understand. We're just starting to scratch the surface of what reality truly is. But here it is. This might be the most poetic truth in all of science. The carbon in your skin, the calcium in your bones, the iron in your blood, none of that stuff was made here on Earth. Those elements were forged in the fiery hearts of stars that lived and died billions of years ago. When those stars exploded, they scattered these building blocks of life across the galaxy. We are the direct descendants of those stars. We are literally made of stardust. So when you look up at the night sky, you are looking at your own cosmic family tree. So in the end, we're not just living in the universe, we are the universe. Through our consciousness, our curiosity, our science, the cosmos has found a way to become self-aware. This little blue dot isn't just the stage for our drama. It's the place where the universe woke up and started to wonder about itself. And that right there makes our brief moment in the sun truly special.